So the second question is, what is the impulse at time equal to 0? Huge force applied by the car engine for a sudden start, but that huge force is applied for a very small time interval. So F into T is said to be impulse. So F into T, before that, remember, before time equal to 0, the velocity u equal to 0. The car is not moving, I told you. Here the car is not moving. Here actually the car is actually moving. The car is moving with a uniform velocity. During this interval, the car is moving with some fixed velocity. The position time graph will be a straight line if it is moving under a uniform velocity. So OA, the car is moving with a fixed velocity. The fixed velocity is very easy to find out. How? That fixed velocity is very easy to find out. Velocity is equal to distance divided by time. Velocity is equal to distance divided by time. Distance divided by time. I will write here, let me write all possible steps. When time equal to 0 second, what is the position? Let me write it in words. When time equal to 0 second, where is the position? 0 meter. When time equal to 4 seconds, when time equal to 4 seconds, when time equal to 4 seconds, the position of the car is 3 meter. The position is 3 meter. The car is moving with a fixed velocity from O to A. So velocity, I will explain why we are finding velocity. Let me find it out. Velocity is equal to displacement by time. Displacement means from 0 meter to 3 meter. How much distance car traveled from position 0 meter to position 3 meter. The car has traveled 3 meter distance. The car has traveled 3 meter distance. 3 minus 0. The car has traveled 3 minus 0 distance. Time interval? Time interval is 4 minus 0. Velocity is equal to distance by time. In a 4 second duration, in a 4 second duration, the displacement of the car is 3 meter. So the displacement divided by time is the velocity. 3 by 4. I will interact with you. Let me complete some 2 or 3 steps. So O to A, the car is moving with a fixed velocity 3 by 4 meter per second. The car is moving with a fixed velocity 3 by 4 meter per second. So the car was stationary. Immediately there is a sudden start. Immediately after time equal to 0, the car has got a velocity 3 by 4 meter per second. Till A. Till A. Okay. Okay, all of you clear? Understood? Aryan, Deva, Nadasha. Nadasha, കുറച്ച് കഴിയുമ്പോൾ ക്ലിയർ ആയിക്കോളും. കുറേ ഐഡിയ വരും കുറേ കഴിയുമ്പോഴേ. Rakshana, understood? So, Aaron, please respond. Please respond.
Yes, sir.
Okay. It's a very important question taken from textbook. I'm going to use the second formula. What is this M? M is the body, mass of the body. Mass of the body is given, see, 4 kilogram. Mass of the moving body is given 4 kg. So M is 4 kg. You may take M outside. That is a good step. M can be taken out. V minus U will be there inside the bracket. V minus U will be there inside the bracket. In this way you have to proceed. M is the mass of the moving body, I mean car, let it, or whatever may be. M is given as 4. V is the velocity after the huge force, 3 by 4. U is the initial velocity just before huge force, 0. So you will get 4 into 4, you may write it, okay, no problem. 4 into 3 by 4, what is this? 4 cancel, 3. The unit of impulse is Newton second. I explained in the previous class. Force has the unit Newton, time has the unit second, hence Newton second is the unit of impulse. So impulse at time equal to 0. So impulse done by the car engine, or the effort done by the car engine will be 3 Newton second for the sudden start of the car. So you please write down till the step, you please go through all the step, and you can ask me doubt. Deva, Aaron, you please ask me doubt. If you are 100% clear, then you can raise your hand. Nadasha, wait here, Nadasha. Okay.
Okay.
Correct, don't worry. Correct, clear. Deva, Aaron, Aryan, everyone okay, clear. Okay, till this step. Now I am going to find out there is another impulse. Where is the another impulse? What is happening at A? What is happening at A? The car was moving with a fixed speed till A. The car was moving, let me say car, okay? The car was moving with a fixed speed till A. Immediately after A, the car has got a sudden stop. Sudden brake is applied, understood? Exactly at A, I mean at time equal to 4 seconds, a sudden brake is applied on the car. The car has got a sudden stop. So huge force applied by the brake system. The car brake system has applied a huge force for stopping the car. So here also there is a huge force exerted by the braking system for a small duration of time. So here also there is a huge force, a small duration of time. So at that time equal to 4 seconds also there is an impulse. Impulse, you think like that, effort done by the braking system. You may think like that. Impulse at time equal to 4 seconds I want. Just before sudden stop, the velocity was 3 by 4. After sudden stop, the car is not moving. Let me use some letter, say V dash. V is already used. V dash is equal to 0. After sudden stop, will the car move? If the sudden brake is applied, the car is stopped. It will not be moving. So initial velocity is 3 by 4 at A. The final velocity is 0. So huge force or huge effort done by the braking mechanism. So what is the effort done by the braking system? Impulse is basic formula is F into T, but the force applied by the brake we have no idea. So we have to use the second formula, final momentum minus initial momentum. Final momentum will be m into v dash. Mass into velocity is the momentum, right? The final minus initial, mv dash. Initial momentum just before applying the brake. Just before applying the brake, the velocity was 3 by 4. The initial momentum m into v. Final momentum minus initial momentum will be the impulse at time equal to 4. Here also you can see that m is common. M is common in both the terms. You can take m outside, v dash minus v. I will explain, I will clarify all your doubt, but let me complete the solution. Mass of the moving body is 4 kg. V dash is 0. Minus v is 3 by 4. You will get 4 into minus 3 by 4. 4 cancel. You will get minus 3 Newton seconds. Minus sign indicate that the impulse turns towards left, meaning that the car is moving towards right. A sudden brake has to be applied for stopping the car. So braking system has done an impulse backward to stop it. So negative sign of the impulse means the huge force is towards left. Impulse positive means the huge force towards right. That's all. Okay. So anyway, you please write down and ask me your doubts. If you are 100% clear, you can raise your hand. Aaron, Rakshana understood. നടാഷ കുറച്ച് കാര്യങ്ങൾ ക്ലിയർ ആയിട്ടുണ്ടാവും, എന്നാൽ ഫുൾ അറിയില്ല എന്ന് എനിക്കറിയാം. ഓക്കെ, ആര്യൻ ഓക്കെ, ഓക്കെ, all of you clear. Next is there are questions based on forces. There are questions based on forces. So in order to do such kind of question, we have to learn vector. That mathematical concept is included in this chapter. If you open the textbook, you can see that we have to do more problems based on forces. I mean, there is an object here, somebody push the body by applying some force, say F1, another person applied a force like this, third person apply a force like this. What is the net force acting on the body? In order to do such kind of question, we have to learn a mathematical concept, vector. Such theory is already there in the textbook, so I have to discuss that. Actually, the concept vector you will learn in the chapter 12th standard. In 12th standard maths, vector is there, but we must know vector initially, then only you will be able to solve this type of question. The multiple forces acting on a body. What happens to the body? In which direction the body moves? What will be the acceleration of the body? What will be the net force acting on the body? To answer such kind of question, you must learn a mathematical concept, vector. 1 minute. Okay, so remember, there are questions based on this mathematics, okay, in textbook. If you open the textbook, there are questions based on this, so we must learn it. So let us learn vector. So you understood why we are learning vector. You understood. The reason is we want to do more problems based on forces. To learn that, to do that kind of question, we must know vector. So give a heading, not a new chapter, the same chapter. You give a heading, vector. We are going to learn a mathematical concept. Have you written the title, vector? Rakshana, Deva, Aaron.
Yes.
Okay, vector. Have you heard about the term vector anywhere? Please tell me. Anybody? Have you heard about the term vector anywhere? നടാഷ കേട്ടിട്ടുണ്ടോ വെക്ടർ? ആരോൺ, ആര്യൻ. വെക്ടർ മീൻസ് yes, very good. The quantities having both magnitude and direction. The force is a good example. Force, for example, the vector concept is required. Vector means, I will explain. The vector means the physical quantity. Physical quantities having, let me write the definition, both magnitude and direction is called vector. Example is force. We have already studied force, but for learning multiple forces, the study about the vector is required. The force is a vector quantity, no? The force, the magnitude is 20 Newton, 30 Newton, like that. And also the direction plays very important role. If we change the direction of the force, the direction of the motion will be changing. So the direction is there for the force. Then any other example? Can you give me any other example? Anybody? Rakshana, please respond. Deva, is there any other example for vector quantities? Direction important.
Distance.
Velocity or displacement. Displacement, yes. Displacement is a vector quantity. This theory is there in our syllabus, okay? There are questions in exercise, so we cannot skip it. Displacement is a vector quantity. For example, I travel 20 meter towards east direction. East direction. If I simply say I travel 20 meter, so it is incomplete. In which direction I traveled? It's very important, right? So magnitude is 20 meter. The direction is east or west, like that. So displacement has both magnitude and a direction. Then another one vector quantity is velocity. Velocity, yes, 10 meter per second in east direction, like that. 10 meter per second is the magnitude, east direction is the direction. Clear? So the vector is clear. Nadasha, please respond. Aryan, Aaron, vector is clear?
Yes, sir.
Okay, we studied that. Let us learn the graphical representation. The diagram is very, very important. Let us learn the graphical representation of vector. Graphical representation. Let me take an example of displacement. Displacement is a vector quantity. It's a good example. For example, you know that before that you know the directions. This direction is east direction. This direction is what? This direction is west, isn't it? This direction is north direction, and this is south direction. You have studied that. So let me explain an example. A person has traveled. A person has traveled 10 meter towards, I don't want to write a long sentence, east direction. It's a vector quantity, right? A person has traveled 10 meter east direction. They are starting from the same point. 3 persons are there, they are starting from the same point. I introduce this with the help of an example. Another person 20 meter travel towards south. Another person say travel 30 meter towards northeast direction, northeast. We can graphically we can represent this. For the time being, let us imagine everyone starting from the same point. So how to represent it graphically? The graphical representation is very, very important. Everyone starting from the same point. A person start 10 meter travel in the east direction. So let us draw a directed line like this. This arrow represents the direction of his motion, and the magnitude is represented by the length. The magnitude is represented by the length, 10 unit, using a suitable scale, 10 centimeter or 10 millimeter, you can decide. So this is the vector, displacement vector of the first person. So the arrow represents direction of the motion, displacement, and the magnitude is represented by the length of this line segment, 10 meter. So using a proper scale, 10 unit you have to measure and draw a line segment. And the next person 20 meter towards which direction? South direction. So 20 meter, draw like this. Arrow represents direction, and the magnitude is represented by the length, 20 units. So it will be double of this. So this is only 10 meter. A minute. Only this much. The first person's displacement is 10 meter. Okay, understood. The magnitude represented by the length. The second person 20 units. So double length. Then third person 30 meter northeast. 30 unit line segment to be drawn towards northeast. Northeast is the direction equally inclined to north and east. Northeast direction is equally inclined to north and east. So that direction. Let me draw it 1 minute. Understood? Like this. The arrow represents the displacement. The unit will be, the length must be 30 units. Clear? So this is the graphical representation. This is the first person's displacement. This is the second person's. The example is required, otherwise you cannot understand that. So the graphical representation is clear. Rakshana, Nadasha, Aryan, Aaron, all of you clear? Graphical representation.
Yes,
So you please write down. Okay, you please write down. If you have finished, please raise your hand. Nadasha, Rakshana, Aaron, all of you clear? Okay, so everyone is clear. Let me go to the next page. So graphical representation is clear. The next is addition. The addition is the most important operations. Okay, addition of two vectors. I will explain with the help of an example. Okay, addition of two vectors. What is the use of addition? First of all, let me discuss why we are adding to vector. Vector means force, displacement. The addition is definitely required. Initially I told you there are some, suppose 2 or more forces simultaneously acting. The net force will be the sum of all the forces. All the forces to be added, it will be the net force experienced by the body. So addition of the vectors is very important. Okay, so I will explain the addition of two vector with the help of an example. Okay, let me explain the simplest case. Let me give a title, the simplest case. The general case I will definitely discuss. Okay, suppose I have traveled a displacement d1. Vector is denoted by symbol like this, an arrow symbol to be written above the letter, meaning that it is a vector quantity. Initially, suppose I have got a displacement. Displacement is a good example for vector, right? I have got a displacement thus, and after that I got again I got displacement. After that again I got another displacement d2. What is the net displacement? Initially I got a displacement d1. I travel my journey from this point. Initially I got a displacement d1. After that once again I got a displacement d2. Simplest case, in the same direction I am traveling. What is my net displacement? Anybody? Net displacement magnitude will be suppose direction, let it be east. Suppose this is 3 meter and this is 4 meter. My net displacement will be having magnitude 7 meter. You agree with me? Rakshana, Nadasha, Aryan. My total displacement will have the magnitude 7 meter. You agree with me? Hello? Not responding. It's a very simple fact, right? So that is addition. Okay, that is addition. So let me write here, this is simplest case. The general case is important one, but let me start with the simple case. So in this particular case, the addition sum of d1 and d2 denoted by, let me denote by some letters, say a and b. We can denote by a and b, okay, or d1 and d2, no problem. A and b are the two displacements. So A plus B has direction. It is east direction, right? I am traveling in the same direction. A plus B has direction. Has direction east itself. A plus B is the net displacement. Direction east. And has magnitude. And has magnitude 7 meter. Clear? The net displacement is, I got a displacement 7 meter towards east. Is that okay? I got a displacement 7 meter towards east. So this is the simplest case. We just add the magnitude if they are moving in the same direction. If the displacement or vectors are in the same direction, the direction remains the same. Magnitude is obtained by simply adding them. Okay, the general case is the important one. I started with a simple case. Is that okay? This example is clear to you? Understood? Hello?
Can you explain, sir?
I will repeat. What happens? Is there any network problem, Deva?
Yes, sir.
Okay, I will repeat. So it's a simple case. Even a 6th standard student can understand. It's a very simple example. Initially, I am standing here. I travel 3 meter in the east direction. Again I travel 4 meter. Again east direction. What is my net displacement? A plus B. A plus B is said to be the net displacement, total displacement. The total displacement has the direction east. The totally I travel in the east direction having magnitude 7 meter. I mean, what is the distance? What distance I travel? 3 plus 4, 7 meter, right? So my A plus B is the net displacement, has the direction east, and magnitude will be 3 plus 4. So totally I travel 7 meter. That's the meaning. Okay, clear? Nadasha, Aryan, Aaron, all of you clear?
Yes.
But I want the general case. If I start with the general case, you may have a confusion. So that's why I started with the simple case. The general case is the most important one. General case. It is not necessary that I will be traveling in the same direction. After traveling in the east direction, can I travel in the west direction or north direction? Yes, it is possible. So that is what I am going to discuss. Okay, this is the initial displacement vector A. For example, 3 meter towards east, for example. And after that, I got a displacement, but not necessarily in the same direction. I travel in another direction, maybe northeast or north direction. Anyway, I can travel. What is this? I got another displacement B. For example, 4 meter in the northeast direction. What is my net displacement? The displacement, the meaning of the displacement is, what do you do, how will you find the displacement? Is it my initial point? I started my journey from this point. And finally, what is my final destination? Finally, I reach here. So my net displacement is obtained by simply joining the starting point and final point. This will be the final net displacement, or A plus B. Clear? For displacement, not distance. Displacement, what we do? We just join the initial point and final point, draw a straight line. That is the displacement. The magnitude of the net displacement is measure the length. Direction, arrow. So in this way we can add the two vector. So the two vector can be added. Addition means we can find out the total displacement, or we can find the total force. So for addition of two vector, the two vectors to be drawn like this, and draw the third side, we get a plus b. Okay, so in short, okay, no need, this much is enough. So this way, in this way we can find out a plus b. This is a law. The statement is not required for us. It is said to be a triangle law. Only diagram is required. The statement is not required. Triangle law. Triangle law of vector addition. Triangle law of vector addition. So what is this triangle law? Triangle law means, suppose I want to find out a plus b. A and b, for example, displacement. Suppose I want to find out a plus b. What do you have to do? A is drawn, b to be drawn at the end of a. To find out a plus b using triangle, what is to be done? First draw a, then draw b. B to be started, b to be drawn from the end of a. Remember, it's very, very important. B to be drawn from the end of a. I have two successive displacements. A is drawn from the end of a, draw say next one b. Join the starting point and final point, complete the triangle. Joining the starting point and final point, complete the triangle. The third side is the total displacement, or total, I mean sum of a and b. Sum of a and b, a plus b. So the arrow will be from the starting point to final point. This is a law which is said to be a triangle law of vector addition. Okay, so the statement is not required. You understand the diagram. Diagram is the most important thing. So there is another law is the, you please draw all these things. If you have finished, please raise your hand. Aaron, Rakshana, Nadasha. The triangle law is clear. A and B to be drawn. Third side represents A plus B. Okay. All of you clear. Aryan, have you understood Aryan?
Yes, sir.
Okay. Then we can find out A plus B in another way. We can find out A plus B in another way. Geometrical method. I am discussing the geometrical method. A and B are given. We have to find out A plus B in another way by drawing a parallelogram. I will explain. Look at this. Initially I got a displacement vector A, right? Let me redraw A. Let me redraw A again. The length and direction remains the same. I am just redrawing, that's all. I am just redrawing the A. The length direction remains same. The same A is drawing. Geometrically I can find out A plus B in another way. The A is drawn. Then another displacement is B. After that I got another displacement B. Let me draw B with the same length and same direction. The same B is drawn without changing magnitude and direction. But here in this case I have drawn A and B having same starting point. Geometrical method of finding A plus B. I am discussing geometrical method of finding A plus B. So A is drawn exactly in the same way. The same length is maintained, same direction is maintained. And next is B. Yes. Same length is maintained, same direction is maintained. But A and B to be drawn in such a way that both of them having same starting point. Now I am going to complete a parallelogram. I am geometrical method of A plus B I am discussing. Using A and B as adjacent sides, complete the parallelogram. Can I complete a parallelogram like this? Yes. From the same starting point. Let me draw a diagonal. From the same starting point, let me draw a diagonal. This one is also a plus b. Using scale, if you have any doubt, using scale, if you measure this length and this length, you can see that both the length are same. If you using a scale, if you measure this length and this length, you can see that both the length are equal. Both the directions are also equal. So this is another way, geometrically, another way of finding the total displacement. The A and B are to be drawn as the adjacent sides of a parallelogram. The two vectors A and B to be drawn as the adjacent sides of a parallelogram. Then the diagonal starting from the same initial point represents the A plus B. So this is a law. It is called, the statement is not required, understand, this is parallelogram law. In two ways you will be getting same A plus B. Parallelogram law. Parallelogram law. So these are the geometrical method. There are other methods. I will explain the other technique later in next class. These two are fundamentals in vector. You please draw the diagram. If you have finished and if you are 100% clear, then raise your hand. Rakshana Aaron understood. Nadasha Aryan.
Yes, sir.
Okay, clear. Okay, all of you are finished. So the next, there are question in textbook, so we cannot avoid this concept. 1 minute. So this one is over. Then this is about the addition of two vector. So naturally you will have a doubt, if there are three or more vectors, how can we add them? This is about the addition of two vector. Can we add the three vectors or four vectors? Definitely. Let me give a title. Just understand the concept. Next class I will discuss the question from textbook. Okay. Deva. Okay. So addition of more than two vectors. Some title is not there in textbook, but I must include this title. Then only we can do the problems from textbook. Addition of more vectors. More vectors, I mean two, more than three or more vectors are there, how can we add them? I will draw a single picture, then you can understand that. Suppose, let me explain displacement. Listen, initially I got a displacement vector, say A. For example, 3 meter travel in east direction. After that I travel say in some angle, say displacement, say for example 4 meter, so making some 30-degree angle with the say east direction. Then again I travel C. A travel, B travel, C travel, like that, understood? Then after that I travel D. Remember, this is my starting point, this is my final point. A plus B plus C plus D is obtained by the net displacement, isn't it? A plus B plus C plus D is the total displacement, not distance. To find the total displacement, what you can do? No need to draw any triangle. You simply join the initial point and final point. That is enough. See, the total displacement is simply joined by the initial and final point, right? So this point will be A plus B plus C plus D. We don't need any triangle parallelogram in this situation, okay? But adding for two vector, you can either use triangle law or parallelogram law. But for more vectors are there, you simply join the starting and final point. That will be the resultant of all the vectors. So you please draw the diagram. The description is not required. Just draw the diagram, okay? If you have finished, please raise your hand. If you have any doubt, please ask me. Nobody is asking doubt. Nadasha, Rakshana, Aaron, Aryan, all of you clear? Understood? Okay. There are questions based on this. I will discuss that next class. An important point you have to keep in your mind is, I travel, let me say displacement, then only you can understand the concept. I travel A, then later I travel B, later I travel like this. 1 minute. Later I travel, I got a displacement like this. In this case, I started my journey. I started my journey from this point. This point I started my journey. I travel this direction, then B and then C. What is my total displacement? Tell me. I travel A, B and C. What is my total displacement? Anybody? Can you suggest? Can you suggest? Then I will tell you. Total displacement is denoted by A plus B plus C. Since final point and starting point coinciding, I started my journey from this point. Finally, I reached the same point. So, if the starting point and final point is coinciding, my net displacement is 0. Understood? Clear? My net displacement is 0. Clear? I started my journey from my house. For example, listen. I started my journey from my house. I traveled this direction, this direction, this direction. Finally, I reached my home. I started my journey from my home. Finally, I reached my home itself. So, I am still standing at my home. So, the displacement is 0. Initial position is home. Final position is also home. So, the displacement is 0. Understood? So, this diagram is very, very important. If you have a triangle, the direction goes like this. If you have a triangle, the direction look like a loop. Loop means this, this, this. Understood? If the direction look like this, the sum of the 3 vector will be 0. Meaning that the total displacement will be 0. So, you please note, please draw this diagram. If you don't understand, you please tell me. If you are 100% clear, then you can raise your hand. Rakshana, Aaron, clear. Aryan, understood. If you have any doubt, please ask me doubt, okay? Okay, this part is clear. The next is, so the operation addition is clear. Understood? Addition I discussed. The application of addition we will learn later. We have to add the forces, displacements, etc. We will learn the applications later. 1 minute. Just a minute. And let me explain one more operations. Every operations I have to discuss because there are questions based on that. Next, multiplication is there. Multiplication by a number. Okay. Let me write a heading. Multiplication. It's a very simple fact. Okay. Multiplication of a vector by a scalar. Scalar means a number. A number. For example, 2, 3, 4, etc. is said to be a scalar. A number, that's all. 1 by 3, 2 by 3. A number without any direction. A number. That is said to be scalar. Multiplication of a vector by a scalar. Listen, I will explain the multiplication of a vector by a scalar using an example. Okay? The diagram is important. The description is not important. Suppose I got a displacement A. I got a displacement A. I have got a displacement A. Another person has got a displacement 2 times my displacement. For example, I travel 10 meter, another person travel in the same direction but 20 meter travels. Understood? I travel 10 meter, say in the east direction or some direction. The another person, say starting from the same point, another person another person travel in the same direction but 2 times my displacement. Is it okay? 2 times my displacement. Then his displacement vector is denoted like this. Let me draw a separate diagram. His displacement vector represented like this. 2 times displacement means 2 times the length graphically. For example, I travel 10 meter, he travel 20 meter. The graphical representation will be like this. The double length of this one. So we denote it by 2 times A. 2 times A means the same direction of A I traveled. The same direction of A travel, but the magnitude will be double. Magnitude will be double. Direction remains the same. That is the meaning of multiplying a vector by a scalar. In this way we are defining, okay? What is the meaning of 3 times A? 3 times A look like this. Somebody has traveled 3 times distance covered by me. Somebody has traveled thrice distance covered by me but same direction. So his displacement vector is denoted by 3 times A. So remember, multiplying a vector by a scalar or a number, meaning that the direction remains the same but the magnitude is that time increased. Understood? 4 times A will be 4 times the distance covered by me. So multiplying a positive scalar, 2, 3, 4, 5 etc. are the positive scalar. If you multiply a positive scalar, the direction remains the same but the magnitude is that amount of that times will be increased. Understood? All of you please listen, don't leave my class. Let me conclude this. Then another situation, another person travel in the opposite direction but 2 times that of my displacement. Then it is denoted by minus 2A. Another person traveled in the opposite direction of my displacement and double the magnitude of my displacement. Then it is denoted by minus 2A. So minus 2A means minus sign indicate that opposite direction of my displacement vector. Opposite direction. Negative sign indicate opposite direction. That scalar quantity 2 represents 2 times displacement. So what is the meaning of minus 3A? Minus 3A will be like this. 3 times distance he travel. The negative sign indicate that he is travel in the opposite direction. So that's all. Negative sign indicate opposite direction. That scalar number 2, 3 represents what? That times the magnitude. Understood? So in this way we define. Okay, clear? So this diagram is sufficient. So this is multiplication of a vector by a scalar. So all of you please draw this diagram neatly. If you don't understand, you please ask me. This is just a symbol, that's all. Okay, 2 times my displacement 2A, 3 times my displacement 3A, like that. നഡാഷ എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടെങ്കിൽ ചോദിക്കണം കേട്ടോ. ആരോൺ, ആര്യൻ. സിമ്പിൾ അല്ലേ ഇത്, അല്ലേ? So that's all for today's class. Okay, let me wind up the session. Okay, bye.
Thank you, sir. Bye.
Okay.
Thank you so much.
Sir.
യെസ് പറഞ്ഞോ നഡാഷ, പറഞ്ഞോളൂ.
ഞങ്ങൾക്ക് വന്ന് 21-ാം തീയതി എക്സാം ആണ് സർ, ഫിസിക്സിലെ യൂണിറ്റ് ആൻഡ് ഡയമെൻഷൻ. അപ്പോൾ ഈ സർ വന്ന് ഇങ്ങനെ വർക്ക് ഷീറ്റ് തന്നാൽ അതൊന്ന് ഹെൽപ്പ് ചെയ്യുമോ സർ?
അതെ ചെയ്തുതരാം. അതെ ഞാൻ സെപ്പറേറ്റ് ക്ലാസ് വേണമെങ്കിൽ അറേഞ്ച് ചെയ്ത് തരാം നടാഷയ്ക്ക് കേട്ടോ. ഓക്കെ, യൂണിറ്റ്സ് ആൻഡ് ഡയമെൻഷൻ എടുത്തപ്പോൾ ഉണ്ടായിരുന്നല്ലേ നടാഷ? എന്നാലും വേണ്ട, എന്നിട്ട് നടാഷയ്ക്ക് എന്തെങ്കിലും ഡൗട്ടുള്ള എന്തെങ്കിലും ഡൗട്ട് നാളെ ഞാൻ
ഏരിയ ഭയങ്കര പാടായിട്ട് തോന്നുന്നു, ചില ഏരിയയിലൊന്ന് സ്റ്റക്കായിട്ട് തോന്നുന്നു. അപ്പോൾ ആ വർക്ക് ഷീറ്റ് ഒന്ന് സർ ഹെൽപ്പ് ചെയ്താൽ.
ഞാൻ പറഞ്ഞുതരാം. അതെ ഞാൻ എനിക്ക് അയച്ചു തന്നാൽ മതി കേട്ടോ. ചിലപ്പോൾ ടെക്സ്റ്റ് ബുക്കിന് പുറത്തോട്ട് ഉള്ള ക്വസ്റ്റ്യൻസ് നിങ്ങൾക്ക് ചെയ്യുന്നുണ്ടാവുമായിരിക്കും അല്ലേ? പുറത്തുള്ള ക്വസ്റ്റ്യൻ ഉണ്ടാവുമായിരിക്കും തോന്നുന്നു.
ഇവിടെ ടെക്സ്റ്റ് സർ, ഇവിടെ ടെക്സ്റ്റ് ബുക്കിൽ അത്രയും കണ്ടന്റ് ഇല്ല സർ, ടെക്സ്റ്റ് ബുക്ക് ഒന്നും ഉപയോഗിക്കുന്നില്ല, സ്വന്തമായിട്ട് അങ്ങ് നോട്ട്സ്.
കുഴപ്പമില്ല. അതിൽ മനസ്സിലാവാത്തതൊന്നും എനിക്ക് അയച്ചതാ കേട്ടല്ലോ. ഓക്കെ, മനസ്സിലാവാത്ത കാര്യങ്ങൾ അയച്ചത് ഒന്ന് വാട്സപ്പ് ചെയ്താൽ മതി. ഓക്കെ
ഓക്കെ സർ,
ശരി എന്നാൽ. ഓക്കെ.
ഓക്കെ സർ.